1. Hi, in this lesson, we are going to see how to sketch the curve. F of x is equal to x times x minus 4 whole cube. Okay, f of x is equal to x times x minus 4 cube. There are 7 guidelines to sketch the curve. The first one is find the domain. Second is find the intercept. Third is find the symmetry. Fourth is asymptote. Fifth is find the intervals. Intervals of increase, intervals of decrease. Sixth is local maximum and local minimum. Seventh is concavity up, concavity down, and point of inflection. Okay. Now we are going to see step one by one. First is domain. Domain for this polynomial, it is very simple. It is all real number. Domain is all real numbers. Minus infinity to plus infinity, because there is no square root, no ln, there is no restriction for this one. Okay, no denominator. So it is a very simple one. F of x is equal to x times x minus 4 cube. So domain is all the real number, minus infinity to infinity. From this, what do you understand? This curve from here to here, it will start and end. This is from the first term. Second, find the intercept. This is how to find the intercept. There are two intercepts, x-intercept, y-intercept. X-intercept is y equal to 0. How to find out? Y equal to 0. So 0 equal to y equal to x times x minus 4 whole cube. So 0 is equal to x times x minus 4 whole cube. So there are two options. If this is 0, either this is 0 or this is 0. So x is equal to 0 or both are 0. X is equal to 0, x is equal to 4. So we found two intercepts for this one. X is equal to 0 and x is equal to 1. Y-intercept, it is very easy to find out, because you just simply put y-intercept. How to find out? X is equal to 0. X, how, when x is equal to, y equal to x times x minus 4 cube. So if x is equal to 0, 0 minus 4 cube, it will be 0. So y equal to 0. So from this, x-intercept is x equal to 0 and x equal to 4 and y equal to 0. So from this, what do you understand? This is 0 comma 0, the curve will pass, because x-intercept is 0, y-intercept is 0. So this curve will pass, and x is equal to 4, the curve will pass. Okay. So you got, now from the step 2, you got two things. Okay, symmetry. Symmetry, if you find out, if it is f of minus x is equal to f of x, it is a even function. F of minus x is equal to minus f of x, it is odd function. Why we are finding symmetry? If you find symmetry, either if you find it is odd function or even function, then it is very easy, because you have to do in only one side. Other side it is symmetry. You can draw it based on the function. Okay, if it is even function, it is reflect on y-axis. If it is odd function, it is rotate about 180 degree. It is symmetry about the origin. Okay. Now we are going to see how to do it. F of minus x is equal to minus f of, wherever x is there, put minus x. First note it down. Okay, wherever x is there, now f of minus x is equal to, instead of x, I put minus x. Instead of x, I put minus x. Here, instead of x, I am put to minus x minus 4 whole cube. Minus x, I take minus out, so x plus 4 whole cube So the structure changed. So f of minus x is not f of x and is not minus f of x. So this symmetry is none. Okay, this symmetry is none. So what is our problem? If the symmetry is none, you have to do full job. Okay, okay. So it is a step number 3, symmetry we finished. Step number 4, asymptote. Asymptote, if there is no problem in restriction in domain, so asymptote is also there won't be any asymptote. Okay. What is the rule for this asymptote? When x is infinitive, f of x is also infinitive. So asymptote is none. Okay, there is no horizontal asymptote. Horizontal asymptote, vertical asymptote, what is the rule? When x is approaching infinity, f of x approaching plus infinity or minus infinity, f of x approaches to L for horizontal asymptote. For vertical asymptote, when x is approaching, we are from the right to or left. If the f of x is either plus infinity or minus infinity, it is a vertical asymptote. This doesn't happen here. So there is no horizontal asymptote, no vertical asymptote. So there is asymptote is none. Okay. Question number 5. Guidelines number 5. What is the guidelines? Find the interval. This is a very important thing. Until 4 is simple one, but that also very important things. Now step number 5 is very important. Find the interval. Find the interval. Before that, you please note it down. Okay. Find the interval. Now, how to find the interval? When you find dy by dx, that is f dash x, when you find f dash x is equal to 0, greater than 0, it is the positive. When f dash x is less than 0, it is decreasing. When f dash is greater than 0, it is increasing. When f dash x is less than 0, it is decreasing. Okay. Now we are going to do this one. Okay. F dash x is greater than 0. How to find out? Differentiate. F dash x is equal to x, UV formula, x times, how to differentiate? 3x minus 4 square times, if you differentiate x, it is 1. Then plus x minus 4 whole cube, x if you differentiate, it is 1. So what is common here? You further factorize. X minus 4 square is common. 3x, this 3x I am putting here. Okay. Here what is, if I take x minus 4 cube, if I take x minus 4 square, what is the balance? I am asking you.
Huh?
X minus 4. Okay. X minus 4. So x minus 4 square, 4x minus 4, x minus 4 squared, take 4 out, x minus 1. Okay. So f dash x is 4 x minus 1 x minus 4 square. Right? When it is increasing, when it is decreasing. This is the point we have to see it. Okay. It is a, when it is increasing, x minus 1 x minus 4. Okay. 4. When x is less than 1, it is negative. X minus 4 squared is positive because it is a square number. Okay. When x is 1 to 4, it is positive. and this is also positive. When x is more than 4, here positive, here also positive. Okay, so what does that mean? It is decreasing minus infinity to, here if you multiply, minus will come. If you multiply, plus will come, plus will come. So from this, what you got it? Minus infinity to 1, it is decreasing. 1 to infinity, it is increasing. So approximately, if it is decreasing means like this, minus infinity to 1, maybe here, then it is increasing. Okay, this is based on until 5 steps. Okay, now we have to see how the concavity up or down, where the point of inflection, everything we are going to see with the step number 6 and 7. Okay, now note it down until now. F dash x is greater than 0. I am differentiating f dash x minus 3, x minus 3 times x as it is, then differentiate 3x minus 4 squared plus x minus 4 cubed, then x minus 4 squared I am taking out, this 3x I put here plus x minus 4, 4x minus 4, take 4 out, x minus 1, x minus 4 squared, x minus 1, so 4 times x minus 1, x minus 4 squared. Okay, now when x is less than 1, it is negative, it is greater than x minus 4 squared is positive, because here square always positive. Here based on that, it is negative. When x is less than 1, it is negative, 1 to 4 is also positive, greater than 4 also positive. Here why I split that, generally we have x minus 4, here square, so we no need to split out two. We can conclude when x is greater than 1 also, because always this is positive. Okay, so now note it down. Okay, okay. Now f2 dash x. Sorry. Now the step 6 is local maximum or local minimum. Local maximum or local minimum. Local maximum, how to do it? When this is a f dash x, find f2 dash x. Find f2 dash x. 4, when f dash x is equal to 0 means when x is equal to 1 and x is equal to 4, it is called as local maximum and local minimum, and point of inflection also. Okay, f2 dash x means if f2 dash x is positive, it is local minimum. If it is negative, it is local maximum. Generally people will get confused, negative is maximum, negative is maximum. Generally people will negative to minimum. Okay, that mistake avoid it. f2 dash is negative means it is maximum. Suppose f2 dash is 0 means it is an inflection. Okay, now we will do it. 4x minus 1 whole square f dash x, 4x minus 1 x minus 4 square. Okay, f2 dash x, you keep as it is, v 2 times x minus 4 power 1, x differentiate 1, so no need to do it, plus x minus 4 square if you differentiate 4 only. So f2 dash x is 8 x minus 1 x minus 4 plus 4 x minus 4 square. Take x minus 4, 4 x minus 4 take out. So what will be there? Here 2x minus 1. Since we have taken a 4, 8 by 4 is 2. 2x minus 1 will be there. Here what will be there? Plus x minus 4 will be there. Okay. Then 4x minus 4 plus 2x minus 2 plus x minus 4. So 4x minus 4 plus 3x minus 6. Take 3 out. 4x minus 4 times 3 times x minus 2 is equal to 12x minus 2 x minus 4. Okay? Note it down. I am repeating. F dash is equal to 4 times x minus 1 square of x minus 4. Okay? I am differentiating to find whether it is local maximum or local minimum or inflection. If it is positive, it is minimum, negative, it is maximum. Okay, we already found x value is 1 equal to 4. Okay, we will substitute this 1 comma 4 in f2 dash. 4 times x minus 1 is u, v dash 2 times x minus 4 plus x minus 4 squared, v. U dash is 4x minus 4, if you differentiate only 4. Okay, then what is common here? This x minus 1 is common. No, not common. I am just multiplying. 4 times 2 is 8. 8 x minus 1, x minus 4. This side I multiplied, simplified. Here 4 times x minus 4 square. Now what is common? Here this x minus 4 is common. Here x minus 4 is common. Here 8 and 4 HCF is 4 only. So 4 times x minus 4 I take out. So what is balance in this 8 divided by 4 is 2. X minus 1 is there. Plus here square of x minus 4 we have taken only x minus 4. So the remaining x minus 4 is there. 1 x minus 4 is there. 2x minus 2 plus x minus 4. 3x minus 6. Take 3 out, x minus 2. Okay. Here 4x minus 4, everything. This 4 times 3 is 12. 12x minus 2, x minus 4. We got it. This is a f2 dash x. Note it down. This also you copy it. 12x minus 2, x minus 4. This is the f2 dash x. Now substitute x is equal to 1. What will happen? 12 times 1 minus 2, 1 minus 4. So 12 times minus 1 minus 3, it will be 36. No need to find this value. When you come to know it is positive, you can stop it. f2 dash x is positive. That's all. f2 dash is positive means it is local minimum. Okay, so this point is 2, it is positive, local minimum. Okay, this naturally it is minimum only, we no need to do it because it is a decreasing and increasing. Okay, but what point we found out at x is equal to, oh no, this is x is equal to 1. When x is equal to 1, when x is equal to 1, it is what is called local minimum. Okay, then I am substituting. We found x is equal to 1 and 4. In x is equal to 1, either local maximum or local minimum or point of inflection. When x is equal to 4, either local maximum or minimum or point of inflection. At 1 we found it is local minimum because f2 dash is positive. Then I am going to substitute 4. 12 times 4 minus 2, 4 minus 4 is 0. So at 4, so at x is equal to 1, it is point of inflection, local minimum. At x is equal to 4, it is point of inflection. Okay, this point of inflection we can find out in two ways, in two places. One is guidelines number 6, when f dash x is equal to 0, f2 dash x is 0 means that point also we can conclude it is the point of inflection. So at x is equal to 1, it is local minimum. At x is equal to 4, it is inflection. You got it? Okay. Now with the step 1 to 6 we found everything. Only one thing, concavity may be curved like this, or may be curved like this or like this. Concavity we don't know. We know whether it is decreasing or increasing, everything we know. At where the local maximum, where the local minimum we know, but concavity we don't know. Okay, now just note it down everything. Okay. Now, concavity up or concavity down or point of inflection. This is the step number 7. Concavity up. Concavity up means if f2 dash x is greater than 0, it is concavity up. If f2 dash x is less than 0, it is concavity down. Okay. Now, where is f2 dash x we found out? This is a f2 dash x. Okay, f2 dash x. f2 dash x is 12 x minus 2 x minus 4. This is the f2 dash x. When it is positive, when it is negative, you do it x minus 2, x minus 4, 12. f2 dash x. When x is less than 2, it is negative. Here also negative. So f2 dash x is positive. When f2 dash x is 2 to 4, around 3, it is positive, it is negative. So f2 dash x is negative. When x is greater than 4, positive, positive, positive. So when x is less than 2, it is concavity up. When x is 2 to 4, it is concavity down. When x is greater than 4, it is concavity up. This is up, down, concavity up. Concavity up means like this, concavity down means like this. Okay. Note it down, this point. So, from the domain what we found, minus infinity to infinity, the curve will be there. Then second is x-intercept to y-intercept, 0, 4. Okay. Third, what we found, no symmetry. So there is no symmetry. Fourth is asymptote. There is no asymptote. Fifth is intervals. Intervals, when it is increasing, when it is decreasing. Minus infinity to 1, it is decreasing. So until 1 means here it is decreasing, because it is passing through the intercept. At 1 it is decreasing, and 1 to 4 it is increasing. Okay, this is from the step 4 we found. Step 5 we found. Step 6, local minimum. Local minimum is at 1, and at x is equal to 2 we found, at x is equal to 4 we found a point of inflection. Okay, at x is equal to 4 we found a point of inflection. Okay, now the 7th step is concavity up. Concavity up is when x is less than 2. So when x is less than 2, it is concavity up. This is 1, this is 2. When x is 2 to 4, this is concavity down. When x is more than 4, it is concavity up. So we found all these things. Another one point we have to note down. Concavity point of inflection we found at x is equal to, at step number 6 we found a point of inflection is at x is equal to 4. And here another one place we have found a point of inflection is when the concavity is changing, that point is point of inflection. So there are 2 places point of inflection, when x is equal to 2 and when x is equal to 4. Just I summarized. Domain is R, x intercept, y intercept, x is equal to 0, 4, y equal to 0, symmetry none, horizontal asymptote, vertical asymptote, and slant asymptote none, intervals of increase, intervals of decrease first C, minus infinity to 1, intervals of increase 1 to infinity, local maximum none, local minimum. Actual local minimum, you substitute x is equal to 1, you will get 12 times 1 minus 2. Not here, you substitute in 12 in the f of x. If you substitute, you will get minus 27. That is the local minimum. Local minimum happened at x is equal to 1, but local minimum value is minus 27. Concavity up is minus infinity to 2. You see here it is up, and here also up. Concavity up is minus infinity to 2, and 4 to infinity. 4 to infinity also concavity up. 2 to 4 concavity down. Point of inflection 2, minus 16. Here if you substitute x is equal to 2, you will get minus 16. If you substitute x is equal to 4, you will get 0. So point of inflection. And the curve is this one. You see concavity up, and concavity down, and concavity up. I hope you got it completely. If you have any doubts, you put in comment box, I will address you. And see my other videos. I already taken 2 videos in the same to illustrate sketching the curve. I am explaining with the 10 examples. Okay, now this is the third example. Remaining 7 examples are coming. Please keep watch on my playlist. See you then.